Hey guys, and welcome back to the FRQ of the day. This is number 16 for BC and number 12 for AB. It's a shared question again. And it deals with a cone. It's got a funnel actually. It says the funnel has a height of 10 inches and it's got circular cross sections as shown in the figure above. That just means that you could slice it up into circles. At height h, the radius is given by this equation. So what that means, if you think about it, as the height changes, so does the radius. Like the radius down here, way smaller than the radius up here. So this is the equation that will give you the radius depending on whatever height you plug in. And it said that units are in inches. Part A wants us to find the average value of the radius. Now, average value, when you see this, there's a formula for average value that can make this a very easy problem. So average value of a function, you do 1 over b minus a times the integral from a to b of your function. I'm just putting f because that's just kind of the generic formula. What this is doing, you can think about the integral as finding the total, and then you're dividing it by how long it took. It's usually a time interval. In this case, it's not. But that's how you find an average, right? You find the total distance you went divided by your time. Total miles divided by the hours would tell you your miles per hour. So same idea, that's where this formula comes from. But if you know this formula, you can just go right to applying it. So we don't really need that picture. My function for the radius is given to me here, and I want the average radius, so I'm just going to use this formula. 1 over, now my bounds, it tells me that the height goes between 0 and 10. So that's what I can use for my bounds. 10 minus 0. Integral from 0 to 10, and I want my average radius. So I'll put the radius function, 1/20th, 3 plus h squared, dh. Notice how it's dh just because that's the variable that we're using here, so you want to keep that consistent. Okay, so now I just have to solve this integral. So if I'm simplifying a bit, I got 1/10 on the outside here. I'm going to go ahead and pull this 1/20th to the outside too. I always like to pull constants to the outside to kind of get them out of the way. It's okay to do that. And if I keep simplifying this a bit, on the outside now, I've got 1 over 200. And now I'm ready to do this antiderivative because it's just a polynomial. So I'm going to give myself some big parentheses. The 3, I'm going to raise the exponent, so that becomes 3h. Plus, for here, raise your exponent and divide, so we'll have 1/3 h cubed. And for my bounds, we write those with a bracket, and we're going from 0 up to 10. So, almost done with this part. I just need to plug in my bounds and subtract. So I've got 1 over 200. I'm going to plug in the 10, so 3 times 10, plus 1/3 times 10 to the third, minus, then I would plug in my 0, but notice how, look, 3 times 0 is 0, and then this will be 0 also, right? So you don't really even need to write that, because you're just subtracting 0. So what I have here, 1/200th, 3 times 10 is 30, plus 10 cubed is 1,000, so this is 1,000 over 3. Now, you could keep going to simplify this, but here's the beauty of these AP exams. You don't have to simplify that. That's a number. That's fine. In fact, you could have left it here. As long as you just have, a number, you're good to go. So this can be my answer. Now, I do want to put units on it because this was a real applied problem, sort of. You wanted the average value of the radius, and it says that my radius is measured in inches. So this number would be inches. So I'm going to put a box around that. That is my final answer. This was a 3-point question. You got 1 point for your setup. So did you do the integral? You got a second point for having the correct antiderivative. So that's what I did here, doing your antiderivative. Did you do that properly? And then you got your last point for having your answer. So like, did you plug in the bounds and subtract? All right, great. Let's take a look at part B. Let me get some new paper here. Part B says we need to find the volume of this funnel. So this is a volume question. Now, for AB people, you're not going to actually be tested on area volume this year on the AP exam, but we did learn it in class. And BC people, volume is fair game. So, to find the volume of anything, in general, what we do is we do the integral of the area of a slice. And this works for any type of volume, cross sections, revolving, whatever. If I can figure out like the shape of a slice and write an area formula for that, then I can just stick it in an integral and I'll have my volume. So when I look at this, it actually tells me the shape of the slices. We have circular cross sections. What that means is if you're going to slice it up, it makes circles. Like picture slicing it this way. It's making little flat circle disc things. So my circle slices, the area of a circle is pi times radius squared. So I just need to fill this in. I need to figure out, well, what's my radius? Here's something cool. You actually already have an equation for the radius. So guess what? That's r. We'll put that in to this area. Pi times, instead of r, I'm going to put that whole equation, 1/20th, 3 plus h squared, whole thing squared. Pi r squared. So that's my area of one of those circle slices. And so now all I need to do to get the volume, think of volume as a bunch of areas added together. This slice plus this slice plus this slice plus this slice, all the way up. That's what integrals do. They add things together. So I'm going to do the integral to add up all of my slice areas. So I'll put that area formula right in my integral. And because my variable is h, this is a dh. And then my bounds, since it's h, I need my h bounds. And it tells me that h goes between 0 and 10. Okay? So now I just need to solve this integral and I will have my volume. This is my volume. Again, what I would do is pull out all of your constants. So there's a pi. Let's go ahead and move that to the outside so we don't have to deal with it yet. And then it looks like all this is being squared, including the 1/20th. So 1/20th squared would be 1 over 400, because 20 squared is 400. And then this part would get squared, so 3 plus h squared would also get squared, dh. So I'm just squaring each of those. And then let's pull that other constant out to the outside. So I've got pi over 400 times the integral from 0 to 10 of 3 plus h squared squared dh. All right. Now, to solve this integral, I know you might be thinking, ooh, that's going to be u sub or reverse chain rule because it's got a squared. But it's not actually because we don't have the derivative of the inside, right? Like if this is the u, we don't have a u prime. We don't have a 2h. So instead, think simpler. Let's just FOIL this out so that we have like a normal polynomial. Then we can do the antiderivative. So pi over 400 integral. I'm just going to FOIL that out. So 3 squared, that's 9. Then I would have a 6h squared and an h to the 4th. dh. Now, because this is just a polynomial, I can just do the antiderivative piece by piece. I got pi over 400. I'm going to give myself a big parentheses. And for this 9, that's going to bump up to a 9h. H squared will bump up to h cubed. And then we're dividing by that 3. 6 divided by 3 is 2. H to the 4th is going to bump up to h to the 5th, dividing by 5. So I'm putting a 1/5. And then my bounds, put a bracket, and my bounds were from 0 to 10. All right, so hey, I'm almost done. Last step, I just got to plug in these bounds and subtract. And remember, you don't even have to simplify, so it's really not so bad. So I'll plug in that 10, so 9 times 10 plus 2 times 10 cubed plus 1/5 times 10 to the 5th. Then I'll have a minus, and then I'll plug in my second bound. But hold up, look, if I plug in 0, it's going to be 0 plus 0 plus 0. So just minus 0, which you don't even really need to write. Now, you could simplify this further. You definitely could, and it really would be better. However, this is a timed exam, and they will give you credit for this as your answer. So don't waste your time trying to simplify. And what if you make a small mistake, you know? Not worth. So instead, I'm going to leave it like this. Now, I do need some units on here. Remember, this was a volume problem. Volume always has units. And my units were in inches, but volume would be inches cubed. Volume is always in cubed units. So I'm just going to leave this as my answer. All right, and again, this was a 3-point question. Each part of this one was 3 points. You got 1 point for the integrand, which is the thing in the integral. So like, did you get the right area formula and put it in there? You got your second point for doing the antiderivative correctly. So I did this in this step here. And then you got your third point for the answer. Okay. All right. One more part of this question. We'll take a look at part C here, which was also worth 3 points. Okay. Part C says, the funnel has liquid that's draining from the bottom. Oh, this is related rates. At the instant when the height of the liquid is 3. Okay, since I'm already seeing this as related rates, first thing I do is I label all my variables. Height is 3, so I'm going to write down h equals 3. Okay. Then I see the radius is decreasing at a rate of 1/5 inch per second. So what variable is that? It's the rate of the radius. So that is dr dt. Change in radius over time. T is time. And it's 1/5, but I see that it's decreasing. So this is actually going to be negative 1/5, a negative rate of change. And it says at this instant, what is the rate of change of the height with respect to time? So it's asking us for dh dt, height over time. And I'm going to put a question mark because that's my unknown. I'm trying to find that. So that's my first step. I label all of the variables that I see. My next step in a related rates problem is I need to find an equation that has these variables in it. So I need one that has r's and h's. You're in luck because they gave you one. You don't even have to think of what it would be. So r equals 1/20th 3 plus h squared. So I've got an equation, and you're going to want to try to plug these things in, but check it out. I've got derivatives here. So I'm going to need to take the derivative of this equation with respect to t before I can plug these things in. So derivative of r with respect to t would be dr dt. Now when we do a derivative, constants just stay. It's our constant multiple rule. So I'm just going to keep the 1/20th. Derivative of 3 is 0. Derivative of h squared would be 2h, but then because it's with respect to time, I need to put a dh dt. It's like when you do implicit and you put dy dx's for your y terms. Same deal. Every variable has to be with respect to time. So now that I have my derivative, now I can plug in all of these numbers and hopefully I'll be able to find dH dt. So dr dt is negative 1/5 equals 1/20. 2h is 3. Now dH dt is my unknown, so I'm just going to leave it as dH dt. So I have negative 1/5. This is 6 over 20, which is the same as 3 over 10 dH dt. And to get dH dt by itself, you're either going to divide, or I actually prefer to multiply both sides by the reciprocal, so 10/3. Okay, so then you're going to get dH dt over here, and you're going to get negative 10 over 15. That does simplify, so dH dt is negative, that'll be 2/3. And so that's my answer, but remember, you always need units if there are units in your problem. So it's the change in height over time. So my height unit was inches over my time unit. Let's see. If I read the problem, found it. My time unit is in seconds. So this is inches over seconds. And that is your final answer. This again was a 3-point question. You got 2 points for correctly doing the chain rule. So that's your derivative, basically. Did you do the derivative? And they're saying chain rule because you have to put the dH dt. So did you do that right? And then you got your 3rd point for having your answer. All right, guys. Thank you for watching, and as always, if you have any questions, feel free to let me know. Bye!